welcome back. We will today start a lecture on standards of measurements. So, today we will be covering SI based units. We will see meter, kilogram, second, ampere, which is for current, Kelvin, mole for substance present, and then material standards, which were initially in yards, then modern, which is made out of wavelength based measurement, then length and n standards, and finally we will see hierarchical classifications of standards. So, SI based units. So, prior it was assumed that it is in 1793 it is 1 by 10 to the power 7 of the meridian through Paris between the North Pole and the equator. Then interium in 1960s they say it should be 1650763.73 wavelength in a vacuum of radian corresponding to the transition between 2p to the power 10 and 5d5 quantum levels of krypton 86 atoms, that was interium. Currently in 1993 the distance travelled by light in vacuum in 1 by 299792458 of a second. So, this is the latest definition for a meter. It started in 1793, you should see measurements significance started very early. So, they were talking about 1 by 10 to the power 7 of the meridian through Paris between the pole north and the equator. This is what they were saying. Then interium in 1960, it was again they started comparing it with respect to wavelength of krypton 86 atom. Then now they talk about a distance travelled by light in vacuum in 1 by 299792458 of a second is the latest definition for meter. The same way for kilogram also, prior, that was in 1793, it was said as the grave was defined as being the mass then called weight of 1 liter of pure water at its freezing point. That was talked about first for a kg, but currently what we do is we have accepted the mass of a small square cylinder of 47 cubic centimeter of platinum iridium alloy kept in a lab in France. Also in practice, any of the numerous officials replicate of it is accepted to be kg. So, currently this is the definition for kg, the mass of a small squared cylinder of approximately 47 cubic centimeter of platinum iridium alloy kept in the lab in France. When we talk about a second, prior it was 1 by 86,400 of a day of 24 hours of 60 minutes of 60 seconds. So, that was the prior definition. Then interium definition in 1956 came 1 by 315,56925.9747 of the tropical year for 1900 January 0 at 12 hours meridian time. But currently in 1967, this is the latest definition which is now accepted, the duration of 9192631770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium 133 atom is the current definition for seconds. Same way for ampere for current. So, it is prior it was defined in 1881 a tenth of an electromagnetic CSG unit of current. The CSG unit of electromagnetic unit of current is that current flowing in an arc 1 centimeter long of circle 1 centimeter in radius that creates a field of 1 oristated at the center. So, this was prior, but the current definition for current is in 1946 it was defined as the constant current which if maintained in two straight parallel conductors of infinite length of negligible circular cross section and placed 1 meter apart in vacuum would produce between these conductors a force equal to 2 into 10 to the power minus 7 Newton per meter of length is nothing but the definition for current. So, it is nothing but definition for amps. SI based unit for Kelvin. Kelvin is for temperature measurement. The centigrade scale is obtained by assigning 0 degree Celsius to the freezing point of water and 100 degree Celsius to the boiling point of water. This was prior definition. In 1954, the triple point of water defined to be exactly 273.16 Kelvin. Current definition is 1967. We have 1 by 273.16 of the thermodynamic temperature of the triple point of water. This defines the Kelvin. So, the mole prior, the psychometric quantity which is equivalent mass in grams of Avogadro's number of molecules of a substance was the prior definition, and today in 1967 when it was rewritten, the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kgs of carbon 12 of C12. So, that is the current definition for mole. So, till now what we saw was various definitions for basic units. It is not definitions, these are basic units. So, now let us move to the next topic where material standards. So, when we talk about material standards and when we talk about linear measurements, we try to take two standard systems for linear measurement that has been accepted and adopted worldwide are English and metric. English always talks in terms of yards. So, if you look at a cricket match pitch also they say 22 yards. Okay. So, English was they always use yards and metric was in meter system. The problem with material standard used earlier with yards was that the material used for defining the standards could change their size with temperature and other conditions. There is a component of thermal expansion when the temperature goes very high, and when you are looking at very small precision measurements. So, then this carries a very important problem, or this carries a very important point to be noticed. Yard or meter is defined as a distance between two scribed lines on a bar of metal maintained under certain conditions of temperature and support. Why are we talking about support? Suppose you have a bar and this bar is resting on a plate, okay, and assume that there is a temperature difference, the bar might expand or might contract, Same way, when this is in contact, perfect contact with the table can expand or contract. When the table expands or contracts, and if the scale which is touching it is having a surface contact, then this influences both. So, in order to avoid this, what people do is they always try to take a table, try to have pointed supported loads, and then they used to have a scale which is there, and then this scale we will try to maintain the temperature and other conditions for the entire setup. So, now that the temperature influence of the table cannot influence the scale, and these rollers are kept as point contacts so that you can maintain certain uniformity across the scale. So, the material standards, the imperial standards yard is a bronze bar of 1 square inch in cross section and 38 inches in length, having a composition of 82% of copper and 13% of tin and 5% of zinc. All these things are come out because these are at this combination they do not expand or contract, and they know at certain temperature they can maintain it a constant and avoid this thermal expansion. Yard is then defined as a distance between two central transfer lines of the plug maintained at a temperature of 62 degree F. So, this is the bronze bar which is having a cross section. Okay. So, here if you see, this is 36 degree Celsius with the temperature is maintained, and then this is 38 degree Celsius, this is a neutral axis, you have a gold plug and this is a square inch. So, the bronze having all these compositions are written here. So, the enlarged view of the gold plug showing the engraving is given here. Right. So, it is defined as a distance between the central positions of two lines engraved on the highly polished surface of a 102 centimeter bar of pure platinum and iridium alloy, which has a composition of 90% platinum, 10% iridium, maintained at 0 degrees under the normal atmospheric pressure and having a cross section of the web. So, this is the recent change. So, first they were talking about copper, and then this is the other definition for yard they had. So, here is it. So, they have a web which is having a cross section, length is 102 centimeter bar, and this is the terminal line of the neutral axis which is maintained. So, 16 millimeter by 16 millimeter. The top surface of the web contains the graduation coinciding with the neutral axis of the cross section. So, why the cross section is uniform is all through this length. The cross section is uniform and has graduation on the neutral axis. It allows the whole surface to be graduated. The type of the cross section provides greater rigidity from the amount of material involved and is economically, even though expensive metal is used for this construction. So, this platinum iridium is very expensive. So, this composition again is chosen such that it avoids expansion. So, what is the disadvantage of this material standards? These material standards are affected by changing in the environmental conditions such as temperature, pressure, humidity, aging, and resulting in the variation in length. Because these materials keep on, because over a period of time they keep expanding, they keep contracting. So, this is a major influence, and then of course, the humidity which is around may allow them to get corroded. All those things are there. So, the standards, by using this platinum iridium and this copper bronze bar always has a problem, because over a period of time it can change the length. The preservation of the standards is very difficult because they must have the appropriate security to prevent their damage or destruction. The replicas of the material standards are not available for use at other places. They cannot be easily reproduced. It is very difficult. Machining exactly perfect 0, it is very difficult. I will tell you a simple problem. Suppose let us assume you have a disc of 5 millimeter. Disc of 5 millimeter, length, right, and the dia is around about 20 millimeter. You want to maintain the flatness between these two. These two surfaces should be parallel to the highest accuracy of 1 micron. We cannot generate this surface so easily. And here, wherein which all throughout the length of 102 centimeters or maintaining a copper brass, this is extremely difficult for you to maintain, to machine. So, and then once you machine it also, it is not possible for you to replicate several times. So, this is a major problem with the material standards. The comparison and verification of the size of the gauges pose considerable difficulty, and if it is available at one place, so all the calibration has to be done as against this. So, it has to be moved, and then you have to get it done, calibrated, and then it will be moved to the other standards. So, the easiest way of doing it is wavelength standards. So, the length, if I could express in terms of wavelength, so then it is very easy, and it is economical, and there is not a material dependent parameter. By using wavelength of a monochromatic light as a natural and invariable unit of length, the dependency of the working standards on the physical standards can be eliminated. So, that is how the length standards today we always talk in terms of wavelength. According to this standard, meter is defined as 1,650,763.73 into wavelength of red-orange radian of krypton 86 atom in vacuum. So, this is a very important point. We were moving out of material based standards to light based standards. Light is repeatable, light is reliable, light is economical to maintain the standards. So, the modern meter was defined in the 17th General Conference of Weights and Measurement held on 20th October 1983. According to this, the meter is the length of a path travelled by light in vacuum during a time interval of 1 by 299,792,458 of a second. So, this is the definition which is accepted for meter. This standard is technologically more accurate and feasible when compared to red-orange radiation of krypton 86 atom and can be realized in practice through the use of an iodine stabilized helium neon laser, gaseous laser. So, using a gaseous laser, you can try to make a standard and we can try to measure wavelength. So, what are the different types of standards? There are 4 types of standards. One is called as primary standard. The next one is called as secondary standard. The third one is called as ternary standard, and the fourth one is called as working standard. Primary standard are preserved carefully and maintained under standard atmospheric condition so that they do not change their values. So, generally this primary standard will be kept in a country in one place. For example, as far as India is concerned, NPL maintains most of these standards, National Physical Laboratory, and which is located in Delhi. So, here what they will do is they will try to have one standard in terms of length measuring. That means to say they will have a device, maybe a bar or a laser light, whatever it is. They will have one standard which is kept in a very controlled atmosphere, and they all make sure that there is no changes which is happening to it. The next one is called as secondary standards. These are derived from primary standards and resemble them very closely with respect to design, material and length. Any error existing in these bars is recorded by comparing with the primary standard after a long intervals. They are kept at different locations under restricted supervision and are used for comparison with the ternary standards. So, here for example, let us assume the standard sample in India is kept at Delhi. So, then each state will try to have state capital might have capital or any other place might have a secondary standard. So, what do they do is once in a year these standards are calibrated. What is calibration? A process of verifying whether my instrument and the standard instruments, they are working proper. Suppose if there is a error, then they quickly try to find out what is the error and the correction is made. So, this is secondary standard. Secondary standard, so you will have one standard, a masterpiece. In this discussion with respect to length, you will have a masterpiece at Delhi, and then you will have several replicas of this masterpiece at several capital heads. So, this they will try to compare and then they try to calibrate. If there is any error, they make the corrections, and then the standard, secondary standard is corrected and sent to the capital state. Again here it is also having a restricted access or entry. The third one is called as ternary. So, this can be in something like every districts. Okay. Primary and secondary standards are the ultimate control of standards. These are used only for reference purpose, and that too at rare intervals. Okay. Ternary is from the secondary. Primary and secondary they are kept at rare, they are checked rare intervals. This ternary is frequently checked with the secondary and it is calibrated. And the last one is the working standard, which can be at every shop floor. Again, every shop floor or an industry, they will have at their industry something called as sub-primary. And then each industry might have several shop floors. So, there they will have secondary. And last they will have at the bench where the instrument, where the machining operations, it is called as ternary standards. You can have this, but every industry has to check their working output with a ternary. You can have something like this. It is basically a hierarchical. When comparing with the other 3 standards, the materials used to make these standards are of lower grade and cost. They are derived from the fundamental standards and suffer from a loss of instrumental accuracy due to subsequent comparison at each level in the hierarchical change. So, what we are trying to do is primary, from primary it goes to secondary, from secondary it goes to ternary, from ternary it goes to working standard. So, here basically this will be of a very high quality, it will be maintained at a very high quality, room or controlled atmosphere will be there. Next, slightly lower to that, material and atmosphere. the next one will be the common use, whatever we do, and the last one will be at a regular use. So, here it will be more of dial gauge. If you see any dial gauge, at the back side of the dial gauge they say when was it calibrated, and then they when, and then they will also will say next calibration. Behind every dial gauge, every instrument, they will always have this data. So, looking at this data, then immediately the dial gauge or the instrument or the scale gauge, whatever it is, will be sent immediately to the working standards room. It gets checked and then it comes down to the table. Okay. So, these are the subdivisions of the standards. Now, let us get into line and end measurement. Okay. When the distance between two engraved lines is used to measure the length, it is called as line standard or line measurement. You have a scale. So, here is an object. Okay. The distance between two engraving lines, okay, is used to measure the length is called as the line standards. When the distance between the two flat surfaces is considered, for example, I have a box, I have another box, so I measure this surface. So, this is a box 1, this is box 2, and this is a jaw, moving jaw or a fixed jaw, whatever we say. No? So, when the distance between the two flat parallel surface is considered a measure of length, it is known as end standard or end measurement. So, now slowly we have finished all the basics. We are getting into now linear measurement. Okay. The end face of the end standard are hardened to reduce. So, that means to say the end face where there is lot of contact, the end face of the end standards are hardened to reduce the wear, and lapped and parallel to very high accuracy is maintained. So, because see if you see vernier caliper, something like this. So, this is a fixed jaw, this is a moving jaw, right. So, what are we talking about is this surface. So, this surface has 2 points. One, it has to be as flat as possible, right, and then second thing, it has to have a hardened material, so that whenever it is in contact with any material, it reduces wear and tear, of jaw. Why? Because this fellow, if there is a wear and tear, so naturally it is sliding on the main scale. So, the reading whatever you get will be inaccurate. So, here we have seen two measurements, one is line measurement and end measurement. Line measurement is if you try to place an object between two lines and try to take a measurement, it is called as line measurement. Two ends if you take, it is called as end measurement. Measurements carried out using a scale are quick and easy and can be used for over a wide range. For example, you have a tape. This tape, if you want to measure the height of a person or height of a table or width of a table, we use that scale, quickly grab it and then measure it and then come out of it. Even though scales are engraved accurately, it is not possible to take full advantage of this accuracy. The engraved line themselves possesses thickness, making it difficult to perform measurement with high accuracy. That is true. Suppose when you try to take a scale or a measuring tape, this measuring tape has its own sag, or the measuring tape has a small twist. So, whatever we measure, we will always say plus or minus some error will be there. So, we will say okay, it is 163 centimeter, maybe plus or minus 2 centimeter. So, or we say plus or minus 2 millimeter. So, right. So, that is what we say in the measuring scale line, we will line measurement, we always will have some error. The marking of the scale are not subjected to wear. Undersizing occurs as leading ends are subjected to wear. The scale does not have a built-in datum, which makes the alignment of the scale and the axis of measurement difficult. This leads to undersizing. So, what we are trying to say, if you have an object, this when you try to measure the diameter of this object, okay. So, if it is a cylindrical one, it is okay. If it is a tapered one, or if it is obscured component, then we have to make sure the measuring axis and the axis of the instruments should either be parallel or perpendicular to avoid error in measurement. So, end measurement. So, these are line and these are end measurement characteristics. They are highly accurate and ideal for very close tolerance, because you are trying to encapsulate end to end. So, here you will make sure the alignment, everything is proper. They measure only one dimension at a time. They are more time consuming. Okay. So, a tailor always use a line tape only. He never use end to end. Okay. Measuring face of the end surface are subjected to wear, which we have already discussed. They pose a built-in datum, because the measuring face are flat and parallel and can be positively located on the datum surface. A group of blocks slip gauges are rung together to create the required size. The faulty wrinkling leads to inaccurate results. We will see what is slip gauge in the due course of time. So, what is slip gauge at this point of time? Suppose let us have a block. You have several blocks of flat plates which are attached. So, you make sure all these flat plates are attached to each other without any gap. So, how do you make sure? That is what is the rung operation we do. So, they do not have a gap in between, and they also do not have any inaccuracies on the flat surfaces. This is for end to end measurement. This is for end to end measurement. Let us now move to hierarchical classifications of standard. You will have a national standard, then you will have a national reference standard, you will have a working standard, which we saw, national standard. So, if you want to say primary standard, it can be in one part of the world. Then you can have a secondary, which is common to one continent. Then the third one, which ternary, can be according to a nation. Then fourth one can be according to your company. Right. So, it is the hierarchy, we have to see how does it go, and then we have to balance it. So, it is national standard, then national reference standards you have next one, and then the third one is a working standard. Then you will have reference standard for working. So, national reference standards, you have reference standard for laboratory, then working standards, then working or reference standards at a lower grade. So, at every standard you have, then you will also have a reference, which with respect to that nation we have that standards. So, working standard, you can also have inter-laboratory standard. Why is this inter-laboratory standard we talk about? For example, if there is a product which is made up of 5 parts, part A, B, C, D and E, and if all the companies have their own calibration and their own standards, then what happens is, when the same product is moved to the next laboratory, there will be a mismatch or there will be an alignment problem. So, in order to avoid it, what we do is, the working standards whatever is set in the nation will also be set to all the labs, inter-laboratory standards we will refer it, and then everybody maintains almost the same. So, the next topic we will discuss about transfer from line to end standards. As I told you, end standards, if we have, it is here there will be not much of error. In line standards there is a possibility of error. So, we are trying to convert as much as line standard is there to end standards. So, we can reduce the error. A line standard having a basic length of more than 1 meter, the line standard consists of a central length bar that has a basic length of 850 millimeter. So, what we are trying to say is, we are trying to say there is a bar. Okay. The line standard consists of a central length bar. This is a central length bar of 950 millimeter. At both the ends there are blocks. Both end blocks of 50 millimeter each are rung on either sides of the center bar. So, this is a center bar. On either sides, what they are trying to say is, they are trying to say we are ringing with 2 blocks. So, these are the 2 blocks. So, now this is 950 centimeter, this is the central length bar. And this is 950 centimeter. So, what we do is we try to take this as block A, block B, block C and block D. Okay. So, each block put together is for 50 millimeter. So, then it sums up to 100 millimeter, right. So, now what are there are 4 different ways, in which 2 set of block can be used. So, let me write the equation. L equal to the total length of 1 meter will be equal to L equal to this L1 is that 950 plus B, C. So, this I have taken 1 block from here, 1 block from here, B and C. So, if we have 2 blocks stuck on both sides, so we can have 4 different possibilities. What are the 4 different possibilities? And this is your L1, by the way. So, L is the total length of 1 meter, right. So, what are the 4 different ways of combination? L can be written as L1 plus B plus C, then L can be written as L1 plus B plus D, L can be written as L1 plus A plus C, L can be written as L1 plus A plus D. Okay. There are 4 different ways of, because this 4 different ways you can do it. Okay. So, here what are the 4 different ways? 2 blocks are used. So, B, C, A, C, A, then B, C, B, D. So, there are 4 different ways. So, when you try to sum them off, summation of all these things will be 4L equal to 4 times L1 plus 2 times A plus 2 times B plus 2 times C plus 2 times D. Okay. This can be written as 4 times L1 plus 2 times A plus B, and it can be written as 2 times C plus D. Okay. Now, if you want, you can try to represent this A B, you can convert this with C D, and then you can start writing it in different forms. Okay. So, this is what we wanted to convey. So, here this is length bar, and these two we are attaching it with 2 slip gauges. We rung it. Rung it is basically when we try to attach 2 slip blocks, there can be a possibility of air or thin film or non-contact. So, what we do is we make sure that these 2 surfaces are tightly in contact. So, tightly in contact, we try to kill off the thin film whatever is there, and then we try to rung it or ring it, they say ring, and then these 2 are attached properly. Okay. So, we make sure there is no gap in it. So, what we have done here? We have done here that this is a central bar, we have taken a block A, B, or we can take C or D. So, we can join this giving various combinations, and finally, we can sum it up and write it in this form. So, here what we are trying to do is we are trying to, again let us go back to the same example. Okay. So, this is your L1, which is equal to 950 millimeter. This is your A, this is your B, this is your C, this is your D, and this is 50 millimeter, and this is also your 50 millimeter. Okay. And this is what is your 1 millimeter of basic length. Okay. Now, see, if at all there is a small error, so how can there be an error? So, what is happening is, just I magnify, I take A block, I take B block. So, this is A, B, which is supposed to be 50. I take C and D, okay. It is supposed to be 50, okay, and this is also supposed to be 50. So, I put it on a flat plate, on a surface plate, I put this, and then I keep these two blocks, which is supposed to be 50, but if you try to see in a very macroscopical way, I zoom the mistake and other things, I see here there is a small amount of, I would say, x. So, this x, there is a small amount of error or difference in height when I do these two blocks, right. So, when then you now look at it and see, suppose if I take an error and get added to it, so then it looks very difficult for you to get the basic length of 1000 millimeter. I am just taking as an example, and I say there is an x component which is there. So, now how do I write it is C plus D equal to A plus B plus that small difference of x, okay. So, now if you look at it, this is what is A plus B, this is your L1 and this is your x, okay. Before this, so now summation of this 2 A plus B plus 2 is C plus D, and then what we say is we are having a small. So, now this difference, okay. So, now if I go back and try to take the same equation of here, I rewrite this equation here. So, when I rewrite this equation, we write it as 4L equal to 4L1 plus 2 times A plus B plus 2 times C plus D, right. So, now I replace this C plus D by this A plus B. So, now it is 4 times L1, 2 times A plus B plus 2 times, I write it as A plus B plus x, okay, and then I finish it. So, now this, if you try to do it, it will be 4 times L1 plus 2 A plus B plus 2 A plus B plus 2x. What is this x? X is the small error whatever we had. So, now if we try to rearrange, it will be 4 times L1 plus 4 times A plus B plus 2x. So, this is 4L. Now, when you try to divide both sides by L and other things, what you get? L equal to L1 plus A plus B plus half of x, okay. Now, if I wanted to represent this in a figure, so you can go and look into it here. So, you can see A plus B I have taken, L1 I have taken, and there is a half x which is the error or which is some small missing data which has to be there. If everything is perfect, then it is going to be L1 A plus B plus half x will give you 1 meter. When I put C plus D, this half will be extra. So, what will happen is you will see that the end to end gauge, when I put the blocks C plus D, so it is nothing but A plus B plus x. So, it will be a projecting outside. So, what is getting to be project outside is nothing but half x, okay. So, now you are able to understand. So, what we did in these two exercises was we were trying to take a center line and then we were trying to take two blocks of 25-25, add it on both sides, so that we made it an end standard. We converted the line into an end standard, and then from here what we did was we did calculations and we tried to represent, get to know the error also, okay. This is what it is, A plus B, half x is less, C plus D half x is more. Okay, now let us look at a problem statement, and we will work with two problems. So the first problem is a calibrated meter and a bar has an actual length of 1000.0006 millimeter. It is to be used in the calibration of two bars A and B, each having a length of 500 millimeters. When compared with the meter bar LA plus LB, we found out to be shorter by 0.0003. In comparing A with B, it was found that A was 0.0005 millimeter longer than B. Find the actual length of A and B. So, what we are trying to say? We are trying to say, here is it. So, this is now split into two blocks. Okay, this is going to be your L. Okay, this is going to be your A and B. This is your A, this is your B. Okay, and then what we say is, we say between those two guys there is an error of E1, which is nothing but 0.0003. Okay, so this is LA and this is LB. Okay, then we also give you one more data. What we say is, we say A and B. A and B, they also have an error, or this error is nothing but difference in height E1 of 0.0005 millimeter. This is all in millimeter. Okay. So, now what we have to do? We have to, from all these figures what we have, we know that L minus E1 equal to L of A plus L of B, right. We know that L of A equal to L of B plus E2. So, now we get L minus E1 equal to 2 times LB plus E2. If you want to write it on the other way around, we can write it as LB equal to LB 2 times. So, LB equal to L E1 minus E2 whole divided by 2 is equal to LB. Okay. Now, substituting the value of everything. So, now substituting the value of LB is, we can take it as LB. So, LB equal to 1000.0006 minus error of 0.0003 minus 0.0005, right. So, the whole whatever it is, that divided by 2. So, what we get? LB equal to So, now this becomes 1000.0006 minus 0.0003 and minus 0.0005. So, it is approximately 8 you have to minus. So, when I subtract 8 from here, it becomes 999 point, it gone, it is 9, it is 999 and this is 3 and 4, one more here. So, it is 9998 maybe. So, it is 8, 16, so 16 is 8. So, it can be 999.999 and I just have to check. So, if this is one more and this is also one more. So, it is 9998, correct. 9998 divided by 2. So, this LB will be equal to 499.9999 millimeter. Now, if I know this, so now I know Y. So, now I have to calculate A. So, calculation of A will be LA equal to LB plus E. Okay. So, this is going to be 499.9999 plus E. E is 0.005, 0.0005, which is I will try to write the answer here. So, which is nothing but 500.000, it is 4. Okay. So, this will be your L, this will be your LA. So, this will be your LB, this will be your LB and this will be your LA. So, now are you able to find out if there is a small error? How do we calculate? So, first step is you should understand this is the length I want. I have 2 rung, I have 2 slip gauges or 2 blocks, which is expected to be 500, 500. When I put it on top, I find out there is an error. Then these 2 blocks also there is an error. So, now we are trying to find out how to sort out this thing. So, what we have done is we have converted a line scale, line measurement into an end measurement. So, let us try one more problem. So, this problem is also very easy. So, let us look at it. So, there are 3 100 millimeter gauges are measured on a level comparator by first ringing them together and then comparing them with 300 millimeter gauge and inter comparing them. The 300 millimeter gauge actually measures 300.0025 millimeter and the 3 gauges together have a combination of 300.0035. So, the gauge A is so much longer than B, but B is shorter than C by this much. So, determine the correct length. So, we will try to solve this problem. So, first what we do is we try to take L, which is length scale. So, this is L and then next to it we have 3 gauges attached. So, now I have also said this is slightly larger. So, I will try to take here. So, I will do 1 block, 2 block and 3 blocks, right. So, I have said that C, B and A. So, you can see here this is the error which is nothing but E1, okay, and in turn this is my LC, this is my LB, this is my LB and this is my LA. Okay. Now, the next thing in this is your base. Next thing what we have said? We have said that you have LA, then we have LB, then we have LC, right. So, what we said was, we said A, B and C. So, between A and B you will have an error of E2, and between A and error C we have an error of E3 equals E3, right. So, we have E1, we have E2, we have E3, fine. So, now let us solve the problem. So, first what we do is, so we take the lengths LA, LB, LC is given for ABC block when the length is given, and it is said as LA, L equal to LA plus LB plus LC minus E1 will be your L. And then what I said is, I said LA equal to LB plus E2, then I said LC equal to LA plus E3, and then LC equal to LB plus E2 plus E3. Okay. Now, what we do is, thus when you try to substitute all, thus when you substitute each and then do all those things. So, what we get is, we get L equal to LB plus E2 plus LB plus LB plus E2 plus E3 minus E1. So, this can be further simplified as 3LB plus 2E E2 plus E3 minus E1, or it can be LB equal to L minus 2E2 minus E3 plus E1 whole divided by 3. Okay. So, now what you have to do is, you have to start substituting all the values of E2, E3 in this thing. So, what is your E2? E2 is nothing but A is 0.002 longer than B. So, this is your E2. So, your E2 is 0.002. What is your E3? E3 is something taller than E1, right. So, how much was it taller? It was 0.001. It was 0.001. And what is your E1? E1 in the problem is, the 300 gauge actually measures 0.00325. So, this is going to be your E1. So, now if you substitute all the values, you will get your end answer. So, your E1 is going to be, E1 is going to, E3 is given, E2 is given, and E1 is also given from the sum. You can try to get this, and then finally, you can try to find out what is your LA, what is your LB and what is your LC, which is just by substitution you can start finding it out, and then you try to get the answer. You try to solve this, we will post this answers in the solution manual, or in the discussion forum we will try to put this. Okay. So, from the question you can try to get the value for E1 and then you can substitute it here, then what you get end answer will be LA, LB, LC. Okay. So, please try to solve this, and we will post the answers of LA, LB, LC in the solutions. So, to recap, whatever we have seen in this particular lecture is, we have seen first what are the SI base units, then what is meter, definition for meter, kilogram, second, ampere, Kelvin or mole. Then we saw material standards, two different material standards, then we saw yard standards, then we saw wavelength, which is more common, and then we saw how do we differentiate line and end standards, and then we also saw the hierarchical classification of standards. Now, I have a question. So, take home there will be a question for the students. Okay. So, now let us try to take 1 meter long, this is 1 meter long tape, okay, 1 meter long tape. Then let us try to take one 15 centimeter scale, and then we will try to have one more scale which is 30 centimeter, 1 foot, half foot, 2 scales, right. And then we would also try to have one more 30 centimeter. So, it is 60, 75, and then we will have one more scale of 30 centimeter, right. So, it is 30 plus 30 plus 30, 90, 105. So, we have 15 centimeter scale and we have 30, 30, 30 scale. These are scales which are blocks, right. So, now I sum it up and then I try to measure this 1 meter. Of course, there will be a 5 centimeter error. There will be a 5 centimeter error. I do understand. Okay. So, now with this scale, you try to add up the scale and try to measure this 1 meter long tape. And now what I would request you is, I want you to take another set of scales and then try to have all with only 15. So many 15. So, it will be 6 times 90 and then you will have 7 times 105. So, it will be 15 centimeter scale 7 times, which is equal to 105 centimeter. This was 30 plus 30 plus 30 plus 15, it was 105, right. So, now you have 1 meter long tape or scale, whatever it is, you had one, and now what you had was you had pieces of small scales, you summed it up, it came to 105. You had another variable, you did not have 30, but you had so many 15 and also the sum was 105. Now, what I want you to do is try to measure this 1 meter by using these combinations and try to figure out, is there any error has happened between this 105 and this 105. If at all there is a error, try to find out the error percentage between option A and option B. Option A and option B. Suppose if there is error, find out the error percentage. So, it has to be 100%. So, you will have to do it A minus B or B minus A, I do not know that. So, that A, assuming that A minus B, find out what is the total sum coming, and then try to figure out this. So, what we are trying to say is, though we know there is a 1 meter long scale, and if I take a small pieces of small scales, if I sum it up, do I get the same value, or between these two options is there any error? Both are going to be a combination of different scales. Please try to do this experiment for yourself, then you will start appreciating whatever we have learned. And the chapter whatever we have learned, we are talking on micron accuracy. Here we are talking on centimeter accuracy. Okay. So, thank you very much, and let us discuss in the next lecture will be limits, fits and tolerance. Thank you.